In this video, I want to discuss the use of the bubble sort in an array list of objects. It also will help you to understand how pointers works in an array list. So what we have here is an array of 5 students. I've given the class student in the top right hand corner. It basically has 2 attributes, name and age. And they both have a getName and a getAge method. That's the only 2 things you need to understand from this class for this video. So we're working with student that has a name and an age. The bottom left, you'll see the list currently contains 5 students with pointers pointing from each element in the array to each one of the objects. Important to note that an array list is a generic list. That means the pointers from an array list are of type object. So you'll notice that it points to the middle of the object. For us to be able to use this object, getName, getAge, etc., later on you will see that it needs to be typecasted first. So at this stage we're pointing to the middle of the object, and therefore we're just pointing to it. We can't use it as such. For the next few slides, we won't be really sorting the list. I just want to look at the basics of the bubble sort. So the first for loop simply says parse goes from 1 to list.count minus 1. What that means is that you need to go through the list count minus 1 times. The reason for that is after each pass, or after going through the list once, there's always one element that is already that is in its correct position. So if there's 5 elements like this case, and you go through it 4 times, you will know that 4 elements are in its correct position, and the 5th one will then automatically be in the other position. So we only need to pass count minus 1 times. On the right hand side, you'll see that the variable pass thus will go 1, 2, 3, 4 if we have 5 elements. The second for loop says how many comparisons do I need to do for each pass. Now you'll notice here that when I'm passing for the first time, compare goes from 1 to list.count minus pass. So compare will go 1, 2, 3, and 4, like you see on the right hand side. Okay, so let's see what happens when we're on the first pass. That means pass has the value 1, and we're doing the first comparisons. That's when compare is 1. So you'll notice that we refer there inside the for loop to list compare minus 1 and list compare. So when we're in the first pass, the first comparison, we'll be comparing the elements at position 0, compare minus 1, and the element at position 1, compare. So when the inner for loop moves on and compare now takes on the value 2, you'll see on the right hand side, compare minus 1 is 1 and compare is 2. So the second comparison in the first pass would be between elements 1 and 2. So let's see what happens when we start the second pass and the first comparison. So pass will have the value 2, and again compare starts at 1. The for loop always starts at 1 for compare. So we're now comparing compare minus 1 and compare. And that again is elements 0 and 1 in the list. So what would be the last comparison on the second pass when compare has the value 3? Why is it the last comparison? Notice in the previous pass the element at position 4 is now in its correct position, so we don't need to compare anything with that. So the final compare in the second pass when compare is 3 is compare minus 1, element at position 2, and compare, which is element at 3. So the second pass we compare the elements 2 and 3. Okay, let's go back to the first pass and do the actual sorting. You'll notice inside the for loop we have first, which points to student list compare minus 1, and second, which points to student list compare. As we said in the previous slides, we are now comparing the elements at position 0 and 1. So let's first see what we have here. We've got list 0 and list 1. So they are the 2 pointers from the array list that point to the 2 objects that we'll be comparing. Notice those 2 pointers point to the middle of the object because it's a generic pointer, and with those 2 pointers we can't do anything with the object. We can't use get the age or the name, etc. So what we do is we typecast list compare -1 and list compare, and we put the answer in first and second. So pointer first points to the pointer which list compare -1 points to, or to the object which it points to, with the only difference it's now been typecasted. You'll see that first points to the whole object, where list 0 points to the middle. So first now actually points to a student, and we can use it to access a student. The same happens to second. Second points to the whole object, where list 1 points to the middle. But once we've typecasted it in second, we can now use the whole object. So we will be comparing the ages of Xhola and Susan. Okay, so what happens in the if statement? The if statement says if the object which first points to his age, in this case is 21, is greater than the object for second, which is 19, then they need to swap. So first points to Xhola, which has an age of 21. Second points to Susan, which has an age of 19. So we need to call the swap method. So you'll see the swap method on the right hand side takes in the parameters 0 and 1. So those are the 2 elements that needs to be swapped. So our attention now goes to the swap method on the right hand side, and the first statement says object temp is assigned to list X. In English that means temp must point to the object which list X points to. Because temp is typecasted as an object and not as a student, it points to the middle of the object. The advantage of this is that the swap method will thus work for swapping any type of object, whether it's a student or a car or whatever. We don't need to be able to use the whole object in this method because we're just going to be moving around pointers, so we can keep it as object pointing to the middle. So you'll see that temp now points to the middle of the object. Okay, then we say list X is assigned to list Y. X is 0, Y is 1, so the pointer list 0 now changes to point to the object which list 1 is pointing to. So you'll see the bottom left list 0 changes. The last statement in the swap method says list Y, which is 1. List 1 is assigned to temp. So it simply says list 1 must point to the same object which temp is currently pointing to. So you'll see list 1 changes to now point to Xhola. So when we return from the swap method inside the BubbleSort, list 0 now points to Susan and list 1 points to Xhola. Very important to note that the actual objects are not moving around. It's just the pointers in the array that we change. Okay, so now we do the second comparison in the first pass. Notice compare becomes 2, and we're comparing list 1 with list 2. So first points to list 1, second points to list 2, and you'll notice that first is Xhola, who is 21, and second is David, who is 20. So we expect Xhola and David to swap. So the swapping means that the 2 pointers in position 1 and 2 swap. So list 1 now points to David and list 2 points to Xhola. So at this stage the order in the array is Susan, then David, then Xhola, and then still Peter and Pumza we haven't visited yet. We won't be going through the whole BubbleSort, but just for the last slide let's look what the third comparison implies. This is when compare has the value 3. We will be comparing the element at position 2 and the element at position 3. So we're comparing Xhola with Peter. First points to Xhola, second points to Peter, and therefore we'll be comparing these two. But the process just now stays the same and is repeated.